I stocked up on some cake, and I'm going to eat that, a little saffron cake, and drink some tea. Then I'll start. This is Ghouls and Ghosts, by the way. Okay, that's gonna turn down the music. So that was a bit of Ghouls and Ghosts, Tim Follin. I never played that game. I played a lot of. I actually beat Ghosts and Goblins on the 64i. It was kind of a cute game. It's like it was very hard, but it was kind of cool the way you had like two lives with one with armor, and you can lose the armor, and you can continue. Okay, nice. Um, was just that's like the start in Ghosts and Goblins. Ghosts and Goblins, that was great with the zombies getting going up and kind of, yeah. Just I like those monsters in the beginning. Those were the best actually. Kind of really awesome. A game opening. Okay, so let me just so um, starting now. Stream watcher. Right. So today I would like to do some stuff with the generics. So I don't think anyone is kind of listening right now, so this will be just for you who are on YouTube, I guess. So to recap, there were two problems left to solve, and one was the locals. And I did some work when I do that earlier today, yeah, and solve that. I don't know if like it's a good way to solve it. That reminds me, maybe I'll look at that. So there's a problem with this, I guess, right? So you should go instead, like if it's not in those symbols. Okay, so we're gonna go for first. We're gonna look at in the unit symbols. Unit has local symbols, and if we have the declaration then there, then we are fine. Return that one. Otherwise, we just return module find symbol. So the module and the symbol. I think this should work as well. Oh, deck. Deckle. Right, let's see if this works actually. Haven't tested this. What to work? Right. Because then we have, like, the problem is we have another module, the generic, the const type. I guess we can look at this later, but we can have another, you know, another local bar here, and you just want the right one to get picked up. So we could look at the I can look at the output from this. It's called, let's see, the generic, right? The generic. So okay, it's it looks like this, which isn't great. I guess I won't handle this now, but we are seeing the square, right? And where is the local though? Don't I use local? It should be in here. So we have like, right, so we have baz there, so we can get like int b equals the generic foo 5 int, oh, baz, sorry. So now I have that particular variable. Let's see what happens, and it should be giving me, like, look at this. So it's giving me that one, and we're getting this 75 here, which is because it's a local in one place. Now we're going to do something different with this one, right? So this one is another bar. It's another local, and we are, what should we do? We can create a b here, which is again this thing here. So we are also grabbing the b, just random numbers here. So now we should get both of them, and we should get the right one. Okay, so look at this, right? Bar would shadow a previous declaration. Hang on. Okay, did I call it bar? Bar 2. No, wait. Why is it shadowing a previous declaration? It is a local after all. So this is wrong. Let's handle this straight off bat here. Right. So here we go. We would shadow a previous declaration. And see, we have declared register. Now the local symbols here. So it's in bar int, right? And we are saving it in the local symbols. Too bad I didn't have like any functionality to look at all the elements in a map. Okay, look at the error here. So right, so we are seeing it here, right? And it would shadow a previous declaration, which is also there. What happens if I do something else, like a 6 here? No, they should not be Oh, that works, right? So let's see here. We get the 87, right? And then we get this one, and they are different, of course. One is relating to 187, so that's everything is fine. But the thing is, why is that a problem, having the same one? So if I do instantiating the same things over and over again, right, that shouldn't be a problem. Like if I do this, I should get the old instantiation. I shouldn't get the same thing again. Right, this works. But once I do this, it doesn't work. Right, so we are creating a parameterized. Okay, why do we get another version of this? Like, okay, so if I remove these, right? So we're just seeing this. I can keep that one and turn 0. So we do get an error here. Right? But which is completely unreasonable, by the way. So we are going in here and we're getting the first time, like we're creating the instance once, and then we create it twice. So why isn't that instance matching? We have only 2 of these, so we should be able to see why. Okay, so here we go. Like we are in here, and we do create that suffix, right? So now the suffix is this for int, like lots of dollars, and then again we create it again. Like, okay, so the second time around, oh, do we add? I mean, we must add that to the instances. Look at this, it's added here to the generic. So why does it suddenly don't have any generic? Ooh, hang on. We don't do any. Is it because we don't do any unification? Right, so we are creating these generic decals, right? And for a module, so the generic is found, let's see here. So the first time around, we find one generic, so we get this generic is 660, and the other time we get a 4C8, right? And they are, let's go back. So the first time we get the module, which is module of F20. The second time we go around, we get to F20, but we get like is it the same unit though? Right, so we have the alias, right? So alias, here we go. So in one, the alias is from one unit, and the other case it's from the other. So what happens here is that we need to unify. At some point, we need to unify the generics, and we haven't done this, and that's why everything goes to crap. So, when can you do that? You need to. Oh, you can't do that early on. That's true. So, when do we create these? Right? We create these parameters. Like here we have unified generic decals, right? So I already thought of this. Oh, they have the same ID. Yes, of course, they have the same ID. So we have several generic declarations, but they share an ID. So but when you have one generic, it's a problem when you have this generic which is part of a particular unit, and then the problem is that once you create this you create this instance, that should be shared with all the instances for all the generics. So this is like, let me mull over that. So there is an issue here. So let's write that one down. We already have, like, okay, we have the method. Let's do the methods first, because now we are unify module sections, because this is going to be different later on anyway. So I'll let me defer this. So unifying generics is not going to be like just about units and stuff like that. And so obviously I need to handle them differently later on. So enough of that. So we're going to look at, instead we're going to look at the, we can remove this for now. So right now it just works for one and so on, and okay. So we are this works, right? We have this part and it worked. So all of this works, which is nice, very nice to actually get it to work finally. Just proving it works, right? Okay, so the next thing we want to do is methods. So we have a struct here, so we can create a method that is the struct foo, and so it's going to take a self here as well, and it's going to return a void, or maybe a type. Okay, and then it just, let's say it just returns the value of the first element. So we have self L 0. Well, actually we have contracts as well. This we have to like do contracts. Yeah, there's a lot of things to fix. Yeah, okay, anyway, so this probably doesn't work right now. I mean, it should probably parse it and so on, but yeah, so it doesn't do anything. What we want to do is like s, what do we call it, s foo, right? So and we can take that one and put it in a y. So maybe it works. I'm not sure. I don't remember. So here there is no field or method. It's the struct foo. Okay. So let's kind of backtrack from this, right? So how do we look up methods? We do that by already resolving something and then continuing going further. So there is no field like here, right? And then what is the type here? The type should actually be the I was a bit surprised when I saw what the type was, right? So the type here is the struct, and that is wrong. So if we look at this, okay, actually the name is the struct here, but the type is returned as the struct. So okay, so it's right, it's correct. But if you go into the decl and let's see if it has any methods, right? So if we look at this thing here, the struct itself, where are we? Not the type. Okay, we have it here. No. We have the parent. The parent has a type. The type has a declaration. The declaration itself has methods. Where are those? There we go. No. Up here now. There's so much in here. We are in their type. No, the type. Here we go. Let's see. There's a method table, and there's everything of this becomes more complex because of what we're doing right now. So at this, we have a bunch of different things, but the actual methods are somewhere else. Not in there. Not in there. Oh, maybe it's just a method table. Okay, someone else wanted to be banned. So people sending weird stuff. Okay, so there's no method. And why? Because we haven't registered the methods yet. So if we look at what happens with the generics, so it looks like this. Module, analysis stage, right. So if you look at this, there's the part where you do the register the global declarations, and then later, look, you are adding the methods. So the reason why this was done like this, like you do the rec methods later, is that this way you're supposed to be able to use that for conditionals. The problem with doing it like this is that, first of all, it's still not guaranteed to be right, because when you can then get down to the actual analysis here, things might be wrong. So what I kind of propose is that all those methods, all those precious methods, all those methods should instead be registered early. So we just oh wait, no, why? It's like you haven't registered them yet, so that means the problem is that the type might not exist yet. So we are not able to do the registration yet, and that poses a problem for us, because when we want to register the methods, now what happens like we already made, maybe we already made a copy of something, right? We already used the generics to create a copy of something, and now those methods are not created yet. I mean, those are not added to that particular type. Because they haven't been resolved to belong to a particular type yet. Man, this makes everything so much more complicated. Oh God. I think what we need to do is basically we're gonna save this is fixing locals, right? Because we need to approach this from a different angle. So I'm just going to push this, right? So anyone can look at that. We need to go back to master, right? And we need to do stuff to prepare for what we want to do with the last stuff, right? So, by the way, this should work fine. Doing this with the old stuff should be exactly as is today. So that you can just verify that. Oh, it cannot be. Okay, yeah, that's because I had blah blah. So it's a double, right? So this works. But what we want to do now is kind of do it differently. The methods and so on, we want to do them differently. What we want to do is kind of to put these together. So let's see, we register the method, like see here we get the declarations and then the conditional declarations. And the problem with the conditional declarations, by the way, is that it might rely on, we might be seeing something like creating generic types at this point. And again, if we haven't registered the methods, then we're, it's messed up. So maybe we need to register methods and understand that when we do that, we might need to create generic versions of things. So when we get to this place, we need to look for things. Again, let's see what it does. So it has the generic, like they are splitting things into generic things to register and registering the normal things. And the reason for that is that if you have a type and then that you use for generics, then you might want to ask that type if it has a method, because if it has that method, the generic will work differently. So the problem here is this connection. This openness in C3 makes it possible to add methods at any time, or more or less. So the problem happens when you are using a type dev to add a method, right? So you need to resolve the type and do all that in order to adding this method. So that is the tricky part. And you might want to, like what you could do though is that, like these are at least, I think, not dependent on analysis, right? So here we don't do any type analysis that can go wrong. Like those only happen once we get to the conditionals. And we have the includes. God, I hate includes. Is anyone using includes? Like, if no one is using includes, then we can remove it. Like, that's something. I guess includes would be like, maybe we can do the includes after. No, it's just the CTX and everything is that's include. Man. So let's see here. We are going through, the imports, then everything is fine, and then we do, we do the includes, and then we register conditional units after doing the includes, switching. Maybe we could do, the conditional units. The reason why we want to do the conditional differently because there might be stuff like env, which is saying things, but honestly, I don't know. I don't want to. I could, like the top ones here. Okay, so these are actually in this case they have two uses, the conditionals. So because one is when you do it normally, and the other one was when you're creating a module, right? A generic module, because then we're using this to actually, prune the module. Damn it. So it doesn't look like. I wonder about this though. Why do we do this? Okay, this ordering probably is because they might be dependent. And yeah. I don't know if these have side effects though. Like which ones have side effects? So these are doesn't. Okay, we have a resolve type info, and that one actually has side effects. So as soon as you're resolving any type in C3, you could be invoking methods and macros and so on. So this ordering thing is messy. Means it's messy, but it also gives you a lot of expressive power. So what that means is that you could essentially, for example, you could have a type that depends on the macro. So you can do that very effortlessly. But that means that there are ordering issues that you need to be aware of, basically. All right. So this is of course is master, and we're gonna go to dev again. So we have this issue here now, right? And again, we don't know where things will happen, right? We don't know if these generic things have included all their stuff. But what we can do though is that we don't need to do it. We don't need to do this separately. So I would like to look at whether this is run, like what happens when I run this, because I have I think there's a strong possibility that they don't get registered at all. And if they are, then they need to be. Hang on. These old methods should all be wired up already. Okay, so let's see here. We go get into this place, and what module are we in? We are in the core, and we can just skip it because that one is not. So we are in the generic, right? So now let's see here. So we are going to look through the units, and there's just one unit, and then we are going to look at generic methods to register, and we don't have any. We don't have any. We do have one. So I guess it's either we're not registering that or something else happens. Okay, so let's see what happens. How many times? Oh, maybe we can add some more logging. So we are adding more. This is gonna be like, it's crazy when you do this on normal cases, but this will help us. So let's look at the output here. So okay, so get to we are adding a lot of libraries. That was not important. So we get to the registering the conditional units, and we have done that, and then we are okay. It doesn't give me any information. That sucks. Okay, so but we're gonna go like see what happens when we are registering the global declarations anyway. So okay, sorry, I have to close the door or you will get a bit distracted by that sound. Okay. So let's see here. This is fairly useless. Okay, but let's go in here. So okay, we are in here. We are in what module? We are now in unit module, the generic, right? So we have a bunch of okay, no. This is way past. This is when we're doing this. This is useless. So we want to add. We want to see when we get these added to. Oh, we have that separately. I keep forgetting that. So actually, these stages they are done after we create stuff for the generics. So here we get all the generic declarations and conditional declarations, right? And so even the even stuff like the functions should be in there, which means that once we get to the point where we are doing this, it's in here. So we are getting all those declarations. Okay, cond. We're copying them, blah blah blah. So okay, we're here, right? And then we register all of those. And now we will get things. The thing is, like, sometimes some of these are the methods, right? So what will happen here is that once we register this here, it will go into, so it will go into this subfunction here to register it. And what we'll do is that it will add things to here eventually. So you'll get to, okay, didn't get that. Okay, that was just a macro, right? Okay, so the function, right? So here we go. We have several functions. So just some of them are going to be like the generic, but not necessarily, right? So we have the first declaration, which is the main function. Okay, we're gonna skip that one, and now we have the function foo double. This is the foo in here that we're trying, and then we had this. Oh, that one is called foo2, right? Maybe I just rename that one, or we'll get a bit confused. By the way, does anyone have any questions or something? Just let me know, right? So Okay, we are in unit, in module, and it's in test, which is the main one. And then we continue, and we are in the generic. So here we have the name is what? It's that was the name of the unit. So let me see what the declaration is. So the declaration is foo2. Okay, so this is one that has methods. So this is a method. So we're getting in here, and now it's adding this to the methods to register, right? So this is going to be like a list here of things to register. And now this is interesting. So what happens with this name? Okay, the name is fixed, right? So that one is correct. And we're going to get that to methods to register. But the question is, okay, so we discover this and we don't have these methods to register and register generic, right? So that is the problem. And we shouldn't get like the methods to register generic, I think. Like we could get those. Okay, so let's do those. So maybe this is enough. I don't know. Maybe it's enough. So we are going to, and now someone else comes in here, and now got them to close the door. So if the stage is less than analysis methods register, then we just go to exit. Otherwise, we're going to do parts of these things here that we see in the passes. So here is the one to process the methods, and we do the generic and non-generic. And now I'm not going to care about which ones are generic and not. I think this is probably wrong anyway. So where are we? There we go. Okay, so then we're going to go through the both the generic and the non-generic. So for each, we can do this. For each unit, but we don't have units. We don't have anything special with the units at this point. But we should know the units that we are involved with, though. So we have all these units, right? So decal, and we still have, you know, the list of these copied cond. Copied cond. Why is that it, by the way? We do the copied and the copied cond, and then we add them, yes, to the decals. Okay, so copied. So if decal kind equals decal function, or decal kind equals decal, or we can do reverse one. It's module macro, sorry. If it's not one, then we continue. Otherwise, we can create a sema context using the unit that it is in, and then we get the parent info. You're going to do something. Okay, so the unresolved blah blah blah. Okay, so we have some analyze method register. Okay. Sima analyze method register, right? Then we take the context. And we take the method, which is decal then. And then well, okay, so there's next parenthesis. By the way, let me know that this is sound okay. So everyone's hearing this okay. Just type something and ping me a message. It's kind of boring when the chat is empty. Okay, so let's see here. We have the parent type info, blah blah blah, generic methods to register, analyze method to register. Okay, so if it's not okay, it's blah blah. Yeah, good, thank you. Okay, so we register that one, and then we take this and add it to the correct one. So decal kind. I don't know why they are separate though. So decal unit. So I guess like this will work, because this is kind of storing these. This should do it actually. So maybe this works. I got a compressor to up the volume. Okay, so you think the volume is too low? Is that it? Too much. I don't know if there's anything to. The audio monitoring is off. Track, la la la. Volume is okay. I don't know. I can up the volume a bit if you want to. Okay. So what happens if we do this? Okay, we have something missing here as well. This inner pointer. But let's go for this. Oh man, okay. And it's something you need to apply a filter probably on the op side, but not a priority. All good. Okay, but maybe you can do something. I mean, I have like looked virtually at like nothing in here, so I'm just seeing like, okay, we have some sync offset and stuff like that in ops, but I don't know. I haven't looked if there are like anything like filters or anything. I haven't thought of that. Meters, I don't know. Like where do you add more, like improve these things? I guess there are like a gazillion. I know there's a gazillion plugins and stuff like that. I haven't looked into any of those. So if you have any tips, like suggestions, then let me know. Click on the mic. Okay, add filter. Let's see here. So we are going to click, yeah, filters, right? Audio filters, they are empty. Okay. What should I do? Like a noise suppression or something? Would that be okay? If someone knows? Okay, we got an error. Okay, but let's just add this noise suppression if there is something here. So okay, noise suppression, low CPU. Okay, let's try this. So I don't know if that helped, right? Okay, compressor or right now I just have the filter noise reduction thing. Okay, so compressor. You want me to add the compressor? Is that true? I guess I can see if I can do that. So compressor, okay, the filter is compressor IE. I have no idea what I should change this to. Okay, so I don't know if it's better or worse or something. Let me know. Let me know. Okay, but we got some error here, right? So add compressor and put makeup gain to like plus. Okay, well, I can do that. Makeup gain, compressor, makeup output gain. The output gain. I can put that to like 10 here. So like this. I don't know if this is better or not. Not just, yeah. Okay. Does that sound better? Oh God, it's kind of loud now. Is this fine? You can add. You can. Ooh. You can write something there. Okay, so the struct is defined in a generic module. Did you forget the parameters? So we violate a certain ID here as well. So we are certainly getting some errors here. And I think that the reason here is that we might have done something wrong. Okay, let's see when we add those so we can actually exactly look at when we add this thing here. Oh, we didn't. Okay, so in this case, we need to change the context and say that the context itself is actually knowing about what generic we are in. So we want to say that the generic instance that we are using is our instance. Otherwise, it doesn't know. Okay, so we are doing that first. So this is a kind of a hack, in a sense. Okay, so we get it somewhere else. So the problem is, oh, we type info pointer. Okay, so let's see where we get that, when we get that. So where is that insert? So the compiler, let me put I should really put a breakpoint on that. Here we go. And the fatal error, is an error exit. So error exit, let me have that one there. So if I just put here, then we're going to see where things broke. Right. So we are doing this, right? So we are taking the type parent of the methods. Now here, what's the type parent in this case? Now, oh, maybe it assumes that we resolved or something, but this should never be like the func declaration. So, oh, wait a minute. I didn't exclude the ones that didn't have a parent. So, the function declaration, look at this. Like it inserted something completely irrelevant in some other place. I don't know what the heck this is doing, but why it's doing this, but I have CLI do this consistently incorrectly, over and over again. And I'm too lazy to actually try to figure out why. But it's annoying as heck. Okay, so now we shouldn't get weird registrations. It would be kind of cool if it worked. I expect things to kind of break. Okay, there is no field or method struct the struct foo. Okay, so we're registering this symbol blah 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 in the generic, and we're adding this square, and let's see this here. Register this symbol. Let's register this symbol. But why isn't this method getting added? That's interesting. So okay, we'll go in here, Right, we have the type parent. Everything should be fine. We should hit this. Maybe we don't. Okay, so we do hit this. Oh wait, didn't I change that name? Didn't I change it to foo too? Right? So why doesn't it work? Well, because I picked the wrong name. Now why does it works now? It's almost, then we are almost home. And have to do a lot of stuff. Okay, there's nothing like that. Okay, so or method destructible. Okay, there is no such thing. Right. So let's see what happens. So we're going in here and we're going to add that to the declaration. That's like, we're supposed to be able to do that. Oh, hang on, is the declaration the copy or not? No, it's the copy one. Yeah, so it should be fine. So we're going to go in here. We have like the decal, which is what we want, right? Now this is interesting here. So we're going and we're getting the type info here. So the type info now we have not resolved it yet. So now we're resolving it. We're getting the type. So what is the type? The parent type is the struct. Okay, the struct. But what is it backed by? Is it backed by the new one or the old? Okay, it's backed by this one, so it's fine. And it can have this, so it's going to go to add the method to the parent type. Right, so in here, like we go in here, so we have the name of the method. Now, what's the name of the method? It's the method's name. The method's name changed. Okay. So normally we want to change the name, right? So that's what we do. But if we have a method, we don't want to change the name. So there's this copying single for generic here, which is doing the whole work. And what it does see here is there's name suffix, right? So if we have something, we are going to change that name. So, but we're just going to do this if declaration kind is not, if it is, so it is a decal function, and if it's not a decal function, and decal kind is not a macro, either those or the decal type parent. There isn't one, right? In those cases, we're going to update the name. So we're going to write something here. Keep the name if only change the name if the if it's not a macro or a function. And the reason is that they don't leak into the normal name scope, so we should not change the name here, because the name will dependent on the it works, god damn it, it's amazing. So let's remove one of those. So now we have almost everything, I think. So it's not really should work thing kind of thing, but we can see what happens if I turn on the standard library. So what happens if I turn on the standard library? If I set a yes here, where will it break? Okay, boom, we have something here. So what is that? So, okay. type could not be found when doing this. So here we have something. Oh, this is exactly what I was talking about here. Remember that I didn't do everything, right? We were doing something with the functions, and look at this. The inner function pointers. So what does that one do? So we're going to go here, right? So in the passes. So if we have something, we want to resolve those types. So we're going to make this one external to this. And what happens if we do it like this then? What explodes? If I do it like this, it explodes. No, let's see. There might be another reason why this fails. So, okay, I think it failed on the same thing, right? So we are resolving the function strict, blah 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 function type parameterize. So we're going to this inner function pointer anyway. So right here. And now we are resolving this blah blah blah, the type pointer, and we're going here and going here. Let's see what the context is. So the context here should have the generic instance. No. So why can't these even? Oh, I know why this works. So let's set it to the generic instance to the instance. Right, because it needs to know about this, that it is evaluated inside of a generic instance. Very hackish right now, but oh, it still doesn't work. Okay, let's see here. So in the context, do we know about the generic instance? No, we don't know that. Why don't we not know about that one? So here we are, we have the generic instance null. Up in here, we have the generic instance. So why is that null? Okay, oh, we need to go here, right? Instance is not null. That's clear. So sometimes we'll get to this point, right? So let's see. I think that's this where we can be sure that it should do stuff. So here we have something. Just okay, of course, yeah, we are going to have this like if C generic instance. Okay, I just need some place where I can place this one. Okay, so we are in here right now. And what is the declaration? Just has to be that one. It works. No, that fails. So it looks like that's the first one to fail. So, okay, go back, go down here. We see the context is here. This it is any. We're gonna resolve this one. We're going to just resolve the function declaration here. Let's think about this. Okay, so when we go into this here, we're going to transfer this one for a we're going to take this interface predicate. Why is that not generic? Isn't that generic? If it's generic, you should have generic. Is templated. Not templated. Ah, okay. So why? We have the declaration, which is the interface predicate any. That one is templated. And so we're going to resolve the type declaration inside of it. And that declaration needs to be duplicated as well. Needs to be duplicated as well. Because we're now generic over that thing, we need to resolve it. Like, typically, inner things are not considered things you need to template because so when you copy something, I was just thinking that we don't need to mark up things as templated because we just need the top things. So as you see here, we're just doing this stuff with the extra naming for things that are at the top level. So so like a method would be top level, right? But if you have something like a distinct yeah, and if you have a struct, it will do that recursively. But if you have if you copy one, okay, so if you copy or try to resolve something like an alias, like if you are Sima, we had this problem. Actually, we had this problem already. So we already have, when we do the struct, we want to analyze the struct members. What we did was this. So we kind of set those things to the parent. And so if you have an alias, you want to handle them, they need to be done in the same way. But the problem is like this should probably be done automatically. So if you do a copy and you do a copy of an alias, for example, copy decal, right? So here we are copying. Okay, what? What? I don't think this will this even happen? I think this is like old stuff. or so I thought. Like it's templated. So okay, generic IDs. Like how, why? So what you could do is that you could set, when you do the copy struct, right? It does have a way to kind of fix this. We could say like, okay, let's say like ID is the instance ID. And so now whenever you do something and you see a template, then you say the instance ID equals C instance ID, and then we can insert also at that we have C instance ID. And that would kind of work. Let's see if that actually works. Yeah, it actually broke. So why didn't that work? In what case? So you're copying this for a parameterized thing, and then you never said it. I never said it. So if you copy this for macro, right? Okay, and then we're going to do a copy. Okay, so copy struct is template, and the copy struct instance ID is Decal ID generic instance. So it's like I'm still doing, kind of exploratory coding and see what will work. So that's why it's so ugly. Okay, so we're still not having it work. It still doesn't work, but what I'm interested in is seeing whether this worked already, the stuff that we already had. So without that standard library, do we have things working? And yes, I have some printout that I need to remove. So yes, it does work. So let's see what we did. Now I'm interested in fixing is removing one point of code that I did add for like just testing stuff, or actually I might guess that it could maybe work. That's something I want to remove. That actually fixes things, but isn't good. So so we are analyze this thing with the struct. Struct, when we look at this, yeah. If it's templated, it blah blah blah, and we can remove this. Okay. Now let's see that everything works. No, it didn't work. So it should have worked though, except why do we need the templated thing? Yes. Okay, so is templated. So we don't need that. We can just do this. So we can do like if is, we can do like this. Okay, assert copy is template. In that case, or either it's not template or we have the instance ID. Let's just check. Otherwise, we can always say like the template is false and templated is true, and then we set the instance. So if we have if copy instance ID, in that case, we can just set this to templated and do everything there. Oh, it's still not found. Oh, now I'm kind of curious. So we're doing a copy of a bunch of things, right? So what we're copying is like the struct, right? So since we have an instance, we are going to set template to true, and we're going to set the instance to that. And then we're going deeper here, ref, okay, but we're going to go in here, skip over those. And because we have like a list, so we're going to do the same thing for the members, right? So this thing, we have like the instance already, right? So we can go in here. Now we're going to copy these. Copy. No. Copy. Okay, so now we're going to copy this one and do a copy. And doesn't instance look okay now? So like the instance, the copy struct, it still has the instance ID. So it goes in here. Wait. No. See. Let's see. And C is copy. No, copy is C. So that was right. Okay, so that's fine. If you watch, you have to spot these errors. But I can't do them. Aren't you following along? You could have like Zoding had like 100 people like ready to comment on any problem to see. Okay, now it works. And now interestingly, we could kind of test if it works for the standard library too, right? Because now we are doing this deeper, as we should have. Oh, we are crashing on something else. Oh, by the time we write a file, you have to type faster. Type faster. Okay, so we are in the function body here and something breaks. So we have qsort here, okay. So qsort, right, and it has a function body, but it's lacking the prototype. So it's lacking the type. Let's see what the type is. So type is null. Right. So this function then is template, right? So it's templated. It's a templated one, right? And you have a generic ID of this, an instance of it. But I think that we didn't, like, it's not resolved yet, right? Look, the resolve is not done for the declaration. And why did that happen? So probably something very early. We made a copy, but then somehow we forgot to resolve that particular function before we started to analyze the body. And okay, so we're going to look at when that happens then. So let's see if we can track down exactly where that will happen. So this name here is kind of long. I don't think we can really match that. So template play that instance ID. Instance ID. Okay, here we go. So where's that set? It's set in la la la. No, that was not it. Okay. For generic. So here we do the copy, right? And so look, we're going through them and adding all these declarations and so on. So that means that at some point here, we do have that passing past us. So we can have a declaration. So if the stir equals, okay. I think like stir prefix or something like that. Starts with, and then we have this qsort and it's d name. So we are going to track where that happens. So let's just have something here. And let's see if we can find it before it crashes. Like the interesting thing is like, when does this happen? How far into everything? So okay, so now we know that it's there, right? So we can just jump into this here and see, like, do we do the analysis that we need? So okay, we are past that, so we can go through the copies and do this, you know, do a generic registration of everything. So we have the element type. Okay, there's some declaration. We can put it here, so we can just go through these. So it's element type, it's slice, it's list type, stack element, stack. There is the qsort we have. So what happens with that one? It's going down here, boom. It's a function, so it goes down here into functions. And then we can do a declare register, which is registering that symbol. We add that one, and then we do a bunch of things here, but then we're done. I guess we're going to do this again, so it's kind of uninteresting at this point. So we're in here and we registered all of it. Okay, we probably will get to this point like there, right? So we are continuing here. So what stage are we on? So the stage is now CT assert. So CT assert is, that happens before we start analyzing the functions themselves, which means we should be doing the decals, like this thing analysis should happen. So we go in here, if, whoa. Okay, let's do this from the beginning again. So that would fail it, yeah. So restart. Maybe there's some output as well. Okay, so we already had some broken stuff. By the way, this compiler just made me want to work on my line, but I need to implement attach map such data structures. I don't want to. You can steal them from this project. I have several, so in the C3 compiler. Okay, so we have that. We know that the Q-search is there. Let's see. So we jump here to the analysis right stage, and I guess I was going to say so if the stage is greater than it should be the analysis should be done. That's fine, right? We're jumping here because we know it has to do all of that. Maybe it maybe there's an error. Is that it? So like at this point there are errors found, and so it exits. Could that be it? Because we already have these issues. Okay, so maybe like if we already have problems, like when we get into here, then we don't need to do anything. I think that will resolve the problem that we run into. Because it's about trying to do stuff with things that doesn't work. So now we just get errors. Good. Oh, good. So that was a false error. It was due to a chain of events. So let's see here. We want to remove those test things. Oh, I see that my CPU is like booming with, okay, C-line is eating everything, by the way. So if things are like a bit like if anything is bad, blame C-line. All right, let's see here where we have that small printout that I added. So I'm looking at a different screen now. I'm just not confident in juggling multiple screens with OBS, so that's why it's like it is. Right, I found it. So boom, gone. And yeah, close the window. So by the way, if you want to do like, let me show people some things like I think that the clever, this is not my idea, so I'm not going to take credit for it, but this works really well in the Lexer, you know? So the way the Lexer works in C3 is that we have, like, what we do if you have an identifier is that you kind of start scanning the identifier, right? Like this. We start with 0, of course, and then we just do a running hash on this. So right now it's FNVA 1A, right? But it can be any hash function. And then we go through all this. So as we do that, we can notice what kind of casing. This is just for C3, so you don't need to do this yourself. But here I notice that, oh, it's uppercase and down lowercase. So I know at the end what type of token that I'm expecting, right? So now we have the hash and we know like the type of token that we do have. Okay, so here's the max identifier length, by the way. And we set that to 127. Yes. Okay. Okay, anyway, so now that I have this, I know the type. Right? I have already identified the type to something. So I'm going to send a reference to that and go into the sim tab add. And what the SymTab add does, it already has the hash, so you don't need to hash that. So I just look at the bucket, like go in there. If it's not there, I know that the type is going to be my types that I figured out, right? I figured out maybe it's a type identifier, right? And then I'll set that for that particular node. And this is just, I think this is, I don't remember if it's like this is linear probing or whatever it is. So it's probably linear. Yeah, it's linear probing. Okay, so, but if I find this, right, if I already find exactly the same thing, I grab the type and set the type to whatever is in the bucket. So what that means is like, if I say like have the name ABC, right? And I know that this is an identifier, a regular identifier, not type, not a constant. So I'm going to send it over to SymTab add and say, okay, here's ABC and it's an identifier, and it doesn't find ABC anywhere. Okay, so it just stores it, right? So it's done. The second time, though, it goes in here, it's going to find ABC and going to return, that the type. It's going to change that the type is identical. It's going to be the same, so there's no change actually. But if I do if, so it identify, so I don't know that that's a keyword. So I just send, okay, there's this if, and it's kind of an identifier, and then it goes and find this. Okay, we have if, but it's stored as an if token. So I'm giving you back. So the SymTab app gives me back that the type is an if token. So it won't store anything new in there because I already pre-stored all my keywords into this SymTab symbol table. So I'll get back immediately. I'll get back the token. I need to do this lookup anyway. Like most of the time, I need to do this hashing and stuff, regardless of what I do. So I just, as a side effect, I'll get actually like the lookup of the tokens as well. So it's a clever way. And it's not my idea. I adopted it from somewhere else. So I don't remember if it was from the Cone compiler or something else, but it's clever. I like it. Okay, that aside. So once you have these in turns strings that just work, then you can just compare them. That's also makes things very simple. No string compare unless you have like some strings that are large strings that you're not interning. Okay, but we had some problems, right? We had, look at this. We had so here. Entry is not defined in generic modules. Did collections map? Did you forget parameters? So here, for some reason, now maybe the reason is that this is a method. That could be the reason. But it's also, it's placed in a macro. So we could also think that maybe that is the problem. So let's see, here we have some other case, and in this case, this default initial capacity happens to be also kind of invoked in a different way. So okay, it's inline. Yeah, it's also, no, it's just inline from this one. Yeah, so at this point, this is all these are inlines, right? So inline from here, definition was here, inline from here. So this is saying that, okay, when we do this, probably we're not passing along the correct things. So, okay, where did you mean the constant? Okay, if I can just track this. I'm just going to give this like this is the last thing I'll do. And no, did you mean something? Did you mean in the generic module. This is the one, right? So the name resolve is not parameterized. And we're not having, okay, so let's see why. Oh, that's not it. That's not it. Okay, it's defined in the generic module. I think that was it. Oh no, it's defined. Okay. Okay, so here we go. Right. Okay, so we're resolving the symbol, and let's see what the context is. The context doesn't know. No, it doesn't know what the generic instance is. Okay, why? So we are like in a macro call, right? So let's see what the macro is. So the macro itself might not have said the things right. I think that's probably the case, because when you do this thing with a macro call, then you obviously need to update the look at this. So we are doing this macro and then you are having this call, evaluate call arguments. And then, right, in this case, we're resolving this and in the context, and that context is in the URL module, right? But I think we have like different things. We have the current module, we have the inline, and so on. So let's see, we have the call, right? The general call, and we are doing stuff to say that it's inline somewhere here. I know it is. We are doing that. It's shifting into that macro. Itself. So where do we have that? Copy, copy, copy. Okay. Like eventually we're doing the inlining, but like this is why it's hard. This is why it's hard. Because everything is now these templated things. I wonder if I can attach those to the okay, so I usually want to write Lexa parser to context free. I used the context for the parser, but it was complicating with Alex and Jack and use myself. Okay, but it's weird. So we do get into a deeper context. So this context is in a macro. Oh, we're already in a macro. Right. Okay. So that might be why. So we are analyzing this. Okay, here we have the macro context. There we go. So here we go, the macro context. We set up the macro context then perhaps for this. And then if we know the macro itself, here we go, yeah. Context in it, like we should get something like setting this a macro context. This should be automatic. But we're gonna set the generic instance to the Decal. generic ID. I think this is not shared by something else, right? It's going to be the instance ID. Okay. So. Oh wait, so this is okay. Vehicle pointer 0. Could be 0, okay. Might not be 0. So as you see, so many things that get gnarly. And maybe there was some better way of doing this. But right now, with the features that are in C3, just have a difficult time seeing that. Okay, let's see if that's the same that we had before, right? Yeah, we still, no, we do get exactly the same ones. Now we're getting the problem with this. Okay, let's see here. Hi, borrow checker, by the way. Just caught me at the end of this stream, by the way. So, okay, we are analyzing this and we are in a context that we don't know anything about the generic instance. Too bad. And so we set the context here. Let's see here, the context still, the compilation units, though they are different, right? So we do know that we did something here. Okay. So look at this, we are switching state and pushing to a different to new context. So what I want to do here is I'm just going to say like there's another one. So we're going to switch state. We guess also going to keep like decal generic instance. And so we're storing the context. What the heck? Okay, we're storing the old one. Old. Right. Now the instance is kept. So we create something for a new one here. Maybe a new one. Okay, and then we push the state. And now the new context, it's getting the param generic instance. It's getting the param generic ID. like this. So this will allow it to. It's good looking VS Code skin. Okay. Maybe this will work. Maybe won't. What? Did we just fix everything? Is it just like actually working now? No, I can't believe that. So I'll probably no. It would be nice to be able to actually run the test runner. And no. Okay, it doesn't work. Okay, it's okay. Well, where do we get that? Fail to link, right? Fail to link. Okay, let's see what gave me. So okay, so something somewhere. Oh, I think the creating the external versions of things is broken, so that's why. Well, then I can just do like this and say like we're like methods is working, but then we have to do like mangling. Yay! So the mangling is not done because we have to mangle the external names correctly. So that's what happens here. So we're getting all these weird copies of everything, but they are actually different things. So yeah, I think that that's it for today because otherwise I am like it's already. I think I started when did I start? Right, yeah, 2 hours almost. So an hour and a half. I think that's enough. So I hope you enjoyed watching. I guess we've come a bit further along. So yeah, have a great evening and yeah, bye.